Hello and welcome back. So we're going to continue our demos of Hyperledger Fabric. The best way to go through some of these demos is to work along with me while you're seeing this video. Try it yourself on IBM Cloud. I would encourage you to do that. So in the last lecture, we looked at how to set up your own network, create a channel, add peers, look at the blocks in your network and so on in your channel. In this one, we're going to look at a demo application, a simple application that will transfer marbles. So you can think of it as an extrapolation of what Bitcoin does. Bitcoin is actually transferring assets across. So you're going to transfer Bitcoins from one person to another person. But here's a toy example. You're going to transfer some marbles, right? The marbles have certain properties. It has a color. It has size. We'll look at that, right? And this is a very simple application that you can deploy on Hyperledger Fabric. Of course, you can think of very much more complex applications as well. Apart from just deploying that code, we'll also look at what that code looks like, how you would write that smart contract code, and also write the client application code that will interact with the smart contract itself. And all this, you also get a cool UI with it. I'll show you that along the way. Okay, so I'm going to start by now launching this application first. So let's go first. If you go to the same network that you created last time, the try samples tab here, there are two sample applications that you can deploy. So let's start with the first. The first one is on Hyperledger Fabric. The second one is on Composer. So we'll have a demo of that later. But let's first go deploy this on our network. So this is going to go deploy the Marbles smart contract onto blockchain. Okay, so I was not a member of the default channel, so I was trying to do this as company C, and it did not let me do that. So let me go do this as company A. So I'm going to try and deploy this as now company A. I'm going to deploy Marbles on the default channel. So now A and B are the ones who are going to be part of this application. This was just a sample application. You can of course take the same code and deploy it on the second channel that you had, right? So what's happening behind the scenes? So behind the scenes, what's going to happen is we're going to clone the GitHub repo. So IBM has made this piece of code public. You will clone that into your own GitHub repository. There is a deployment pipeline that will go automatically deploy that code onto IBM Cloud. You'll deploy the smart contracts onto the channel you've selected, and it will also go deploy the application as a separate runtime. Right, so all this is going to get deployed for you. Let's select the region. It's going to be US South again. We're going to deploy the Marbles application. GitHub, I'm going to give my authorization for my GitHub. So let me add that. I will authorize it to clone into my GitHub. So I'm going to authorize IBM Cloud. Okay, so I think that should get done and be reflected here. So now that required has gone away if you see it. So I've already authorized GitHub. And all of these details, you don't have to modify it, but these are some of the configurations that are set up. It gives you the URLs. It says that this is a Node.js application that's being written. A few other things. Let's go ahead and create this. So this is going to take about maybe 5 to 10 minutes. Really depends on your internet speed because it's going to clone some Docker containers. It's going to do a bunch of things. So it says 5 to 10 minutes, likely going to take that much. So in the meanwhile, what we'll do is while this gets created, it also tells you how much has progressed. Let's go and look at the code itself for what the smart contract looks like. Okay. So this is where IBM has made the code public. So this is the Marbles code. This is again gone through various iterations. It's fairly well written, and it's a good way for you to get a feel for what a smart contract looks like. So what is this actually going to do, right? So let's look at this. So we're going to be creating marbles. So each person can say, okay, I have a new marble and add that to the network. So that's one operation. They can transfer the ownership of marbles between people. So if I own a marble, I can transfer that to somebody else. And in that same way, I cannot change the ownership of the marbles that I do not own. right? If I don't own a marble, I can't change someone else's marble to be my own. So that will be prevented. So that will be an access control rule that we will implement. And there are some attributes to a marble. So that a marble has an ID, it has a color, there are multiple colors that are available. It has a size, small or large, and it has an owner. Right? So once a marble is created, each time it could change ownership across people, and all that will be tracked on blockchain. We are calling it marbles here, but you can think of any kind of an asset that is getting that's owned and the ownership can transfer amongst people. Right? So what does the architecture look like? So what we have is there is a marbles application. This application is written in Node.js. It has a client which uses the Node SDK that Fabric provides to connect to the smart contracts on blockchain. Right? So there is a smart contract deployed on each of the peers. This is the marbles smart contract. We'll look at the smart contract also in just a little bit. What does the network look like? We have two peers. This is on the default channel. This is the ordering service, and there are two CAs for that each of the peers connect to. Right? So this CA, actually the peers don't connect to the CA directly. The CA is the one issuing identities, and you're going to use those identities, and the peer will validate those identities. And apart from the Node.js application, we also have a browser UI from which we can trigger transactions via the application onto blockchain. So there's a WebSocket connection between the browser and the Marbles Node.js application. And from the application to the peers, there is a gRPC, Google RPC connection that uses the Fabric SDK to communicate with blockchain. So that's the overall network architecture. So this tells you how to set up marbles yourself. So this will be the next demo that we have, right? So if the IBM cloud makes it very simple for you, just through a few clicks you can experience all of this. But what does it take to actually do this yourself? So we are going to do this as the next demo. So hold your horses for that. It will take you through all the steps. That's right now in those 5 to 10 minutes, whatever is happening. We're going to do that step by step ourselves on a virtual machine that or any other system that you have. Okay, so this is how the marbles will go through the application itself later. But let's look at a little bit of the code itself, right? So let's start with the smart contract code. So let me open up. So if you go to GitHub, there's a folder called chain code source marbles. So I'm going to open that in another tab. So let's go through the smart. So this piece of code that's in this folder is what is getting deployed as a smart contract on each of the peers on blockchain. Right? So this is part of your install and instantiate. So this is the smart contract code that's run in a decentralized fashion. So let's open marbles.go. Right? What does it provide? It first defines the data structures that we will be using. So we have a data structure called marble, right? It has an ID, it has a color, it has a size and an owner, right? Now the owner is actually a relation. It's actually of type owner relation. Now owner relation itself has an ID, username and company, but I think the owner object is a little more interesting. So it has the details about the object type. The main identifier is really this ID field. The rest of it is just cosmetic. Right, so there is a main function, but I think the two important functions to look at are init, and below that there is invoke. Right, what init does is the init function of a smart contract. So this is a required function that you need to implement in your smart contract. What the init function does is it initializes your smart contract with any parameters you need to set. Right, so you can set certain values as initialization in your smart contract. And this will get called at the time of instantiation of your chain code on a particular channel. So you've installed this chain code on a peer, and it's not at the level of a channel at this point. But then you instantiate that chain code for a particular channel, saying I want this copy of a chain code running on this channel. And then there's a separate state for that chain code for that channel, and you will be allowed to initialize that state. So what are we doing in this marbles application? What are we initializing? So here we are going to take one argument, just for illustration of how that works. It's going to be a numeric argument, so you can actually parse this argument. You can send that as an argument to your chain code at the time of instantiation, and you can just check whether it's actually a numeric argument. So this gives you a way to validate any inputs provided to your network. So for instance, you can initialize your network with saying, okay, there are going to be 3 marbles that each of the members are going to own. So I'll create those marbles as part of initialization, for instance. You could do that, but we're not doing that here yet in this example. This just goes through that, and all it stores is just some key. This is again as an example of what you can do. So you can put state, you can add a new key and put some value to it. So you're just storing saying the UI is 4.0.1. Okay, so the initialization step just allows you to initialize, but let's look at the invoke, right? The invoke is what is going to get called each time your chain code is going to get, you're trying to perform a transaction or you're trying to query for some values stored in the chain code, then it comes through the invoke function. So the peer will be calling this invoke function in the chain code, and that's how transactions execute. And everything within this invoke function, whatever is the execution, is going to run atomically, which means that any state you change here, either all of it will change or none of it will change, right? So here, if you look at some of the functions that are implemented, so it implements a simple read and write, but you can do a delete marble, you can initialize a marble, you can set the owner for a particular marble. You can read everything. So tell me all the marbles across all the users. Tell me everything. So that's another query. You can get history for a particular entity. So for a particular marble, tell me all the transactions that have happened for it. Right? Maybe it changed ownership 5 times. Tell me all those transactions. So you can go get history as well. You can get marbles by range. So based on the name of the marble, whatever you've identified, you've given, give me all the marbles between this value and this value in the ID range, right? So you can do that. Okay, so let's go look at some of these examples. So let's go back up a folder, and let's look at writeledger.go. So this has all the functions that are modifying the state of the chain code itself. So these will be committed as transactions on blockchain when invoked. Okay, so let's take one example. I will come back to the delete marble, but let's go to init marble, right? So what init marble does is, as it says in the comments here, it's going to create a new marble with a certain set of parameters. So it takes a few parameters as inputs. So this is an arg string array. It expects 5 parameters. So that's, you can do a check on the number of parameters. And then what are those parameters, right? So it's doing a few checks here, saying the third argument must be a numeric string and so on. Then it's also checks whether the ID you've provided is actually unique. If it's not, then the marble already exists, and you can't try and create a marble that already exists. So you're going to get an error there. So all these errors would result in the transaction itself throwing an error, and you will get that as part of a notification back from blockchain. So your transaction has failed, and you'll also get the error message along with it. Okay, so now all the checks have passed. So we're going to create a new marble. So you're going to set the doc type as marble. There's an ID, color, size, and owner. So you're going to set all of those things as provided in the user input, and you're going to call put state to store that information onto the ledger. So the put state is actually a call to the blockchain ledger, the state database, and you're going to store this key value pair. The key is the ID, and the value is the object representing the marble itself with all of these parameters. Right, so now once the put state is done, you've stored that on a blockchain. Remember, this is just the endorsement phase when this is executed. After this, all the nodes have to execute. It has to go through ordering service. It has to be validated, and only then will it get committed into the final state in blockchain. Right? So that's the process. You can also init owner. So this is creating a new owner, new possible owner in the blockchain. You can set owner for a particular marble. So what this will do is it does the initial sanity checks. It checks if the provided user, the new owner, is actually a valid user. So it does that. It gets the current state of the marble. It tries to find out who is the current owner. So it does a get state. So it goes and looks up the blockchain ledger to find out who owns this marble. Now check who is authorizing this, right? So is the person who invoked this transaction, is that person the owner of this marble? If they are not the owner, then you're not going to authorize them to transfer the marble that they do not own, right? So you have to own the marble you are trying to transfer. So unless you do that, this can't be done. So a word of caution here, this is just meant as a simple example, a toy example. It's actually possible for you to to perform this check using cryptography, right? So you can actually send the credentials of the user or attributes of that user, and you can validate that it was indeed the owner of the marble is indeed the one trying to invoke this transaction. So this check, right now we are just doing it as a simple if condition based on the argument provided. But you can actually do this using cryptographic checks. It's possible to do that in chain code also, right? But we're not demonstrating that here. Okay, all the checks have passed. Now we're finally going to transfer the marble. So you're going to update the record, set the new owner as the owner provided, and you're going to update the argument, the same marble ID. You're going to put that back onto the ledger. So if this transaction goes through successfully across the network, the new owner would have changed, right? So there are other things about disable owner, delete marble, and so on. You can go through that at leisure, right? So that gives you an overview of what the smart contract itself looks like. So it's a bunch of functions that are all manipulating state maintained by the smart contracts, by that smart contract itself. And the state is isolated for each channel. So you can have the same contract running on multiple channels, and they can be managing different state information. Okay, so let's go back to our GitHub and let's look up. We went through the chain codes. What are the other aspects of the application? So the other aspects are the application code themselves. So let's look at that briefly. So this all the application code is inside the utils directory, and there is a WebSocket server-side.js. So this is the server-side Node.js application that we talked about, and this is the one that's going to interface with the blockchain, use the client SDK, use the Node SDK to call blockchain to perform transactions. So what are some of the things it does? It gets the channel ID, it gets the peer URL. So all of these will be configuration parameters for the application. And if you want to create an marble, so this is data type is create, then what it would do is create an object, and it will call create a marble, right? It's part of the libraries folder. So you're going to create a marble with these parameters, and that create a marble will be calling the SDK functions. Likewise, you can also transfer a marble. It calls that. Right. So this is the library function that I talked about. So this has functions for set marble owner, and it'll also have something for create marble also. Right. So the set owner is, if you look at it, it has the peer URLs, the channel ID, this particular chain code ID for this marble's chain code. All these are already set in earlier parts of the code. Right. What endorsements you need, right? And finally, the chain code function to call. So it's going to call the set owner function. We saw this function previously in the writeledger.go file, and it has the arguments that needs to be passed to the chain code. So it sends all of this information. It calls invoke chain code. So this is something in the SDK. So you go invoke the chain code with these parameters, and that will then call the blockchain. It'll send control to the peer to invoke this particular function on the chain code. Okay, so that was the server-side application. So apart from that, you can also have a UI. So we have a UI for this, and there is a UI building the JS, and it has the abilities that you will see. Some of these capabilities you'll see. You'll actually be able to easily drag and drop marbles as a way of transferring ownership. Right? So all those UI capabilities are also available as Node.js code. But that's all of this is now a step removed from blockchain itself. So I'll leave you to see these things at leisure. Okay. So now let's go back to our UI and see, okay, our marbles application has launched. So you will see that it's no longer this black and white picture. There's actually a color picture that tells you, and it's ready to launch. So let's go ahead and launch it. So we're going to launch this marbles application. So this has now been deployed on your default channel that you had previously. You have two organizations, or company A and company B, that are part of this this demo. Okay, so let's go through the guided tour for now. So what are some of the things that are happening in the backend, right? We've kind of gone past this. We just let IBM Cloud deal with all this thing. What are some of the things we're doing? One is the connection profile. So this tells you what is the network, how do you connect to the network, what peer do you need to connect to, who's the orderer, what is the policy. So all of that is captured. What are the channels? I mean, all that is captured in your connection profile. So you need that set. So as part of your network, that will be available in one place. You can actually go look at your connection profile. So next thing is you have to set up identities, right? So you have identities for your admins for each of your organizations. So you have that. You need to have that set up. Then you have to get your chain code, deploy that chain code, or install that chain code on each of the peers, and instantiate that chain code on the default channel on which you want to run this. So that's happening in step 3. So if each of these will also give you the settings that are being used, so you can go through them as well. But all this has been done for you in the background, so it's just telling you what are the things that have been done. And finally, we're going to be creating some assets. So we have 3 marble users, Amy, Alice, and Ava, and each of them are going to be having 3 marbles. So we've already performed some invoke functions on blockchain to create these owners and create the marbles owned by each of them. So let's go ahead and create them. So that calls this calling the invoke functions in the background. So we'll also look at what we can also parallelly look. Let's go to our channels and watch how the block height keeps increasing for that channel. So if you go to look at the default channel, the block height is 6. Right? If you go look at one of those transactions, it will tell you that the marbles _ sample chain code is invoked. This is the UUID of the transaction. It was an invoke and gives you a timestamp as well. So these were all the transactions that were invoked, and all of these were part of block number 5, right, in your channel. Okay, so let's go back to our UI. So everything has been set up. Now our marbles application is ready to use. So as before, as I mentioned before, Amy, Alice, and Ava are the 3 users in this network. Each of them have 3 marbles, but if you will see, they all have different things. Ava has 3 large marbles, Alice has 3 small marbles, and so on. So for each of these marbles, we can easily, in this UI, go create new marbles. So let's add a marble for Ava. We can choose a color. Let's pick a color. And we can say what size it is. And let's go create it. So when I clicked on create, it's actually going to call our marbles application, which in turn calls blockchain, to put that information on blockchain that Ava now has a new marble, purple marble of size small. Right? So that information would be added to blockchain. If you go back and see our channels, the channel height would have also increased. Right? So it would have added one more block here, block height 7 now. Okay, so let's add another marble just for the heck of it. A marble is been created for Amy, and here below it also shows you the blocks. So it shows you that 006, each block has been added sequentially. So what we can do now is we can easily pick up and drag and drop to somebody else, and this really shows a change of ownership. It signifies a change of ownership. So the red marble now belongs to Alice, and a new block has been committed to the ledger. Right? So we can just do it once more. Let's say this is a large marble, and Amy gave that marble to Ava. Right? So some of the other things you can play around with later is you can, for instance, go try and shut down a peer, bring it back up, and it should still show the same state of the ledger. So some of those things you can play around with. So that shows you some of the fault tolerance aspects. I'm not going to show that here. Let's. The other aspect here is in the, again, let me just step back. In the settings place, there is something called story mode. You can actually go enable it. Let's enable it. Actually, it's a pretty cool thing. It tells you what's happening in the background. The story mode is now on. Okay. So let's see. Let's go through this. So I'm going to create a new marble. This is now story mode is enabled. Let's choose green and it's so small. So when I say create, it will actually tell you what's going to happen in the backend. So for instance, the first part of it is you're going to build a proposal, a transaction proposal that has this information about what is this new marble, who is the new owner. That information is created in a transaction. It is sent to the peers for endorsement. The peers will execute the smart contract, the function that was invoked. It will then say, okay, I agree that this is the output of the transaction. It will send that endorsement back. Right? So that's the transaction response. Once the client has collected enough endorsements, it can then submit it to ordering. So the ordering service might get such requests from multiple clients. It will order those transactions and it will say, okay, these transactions have to be now committed into a block. And then each peer, once they get the block from the orderer, they will validate these transactions, make sure there's no double spending, make sure there are no errors, and then it will commit the transactions. So that's the process itself. So it tells you what's really happening in the back end when you do any one of these transactions. Okay, so that ends the demo. But before we close this lecture, I would like to just prepare for the next demo. So far in the last two demos, we had it easy. We had the IBM Cloud do much of the work in the back end, and I just walked through what IBM Cloud is doing in the back end. So in the next demo, we're going to do it ourselves, right? So we're going to do everything from scratch, build a network ourselves. So for that, what I would encourage you to do is be prepared with Ubuntu VM. So that's what I'm going to use in the demo. But you can also use a Mac. It'll work just as well in a Mac. There are instructions out there where I'll show you the pointers for it. And there are a few prerequisites, so please install those prerequisites before you get to the next lecture. So you need Docker, but Docker Compose, Node.js. So Docker and Docker Compose are how each entity of your network, the peers, the orderers, the chain codes, they're all going to be deployed as Docker containers. You need Node.js and NPM, so for some of the application development. You need a Git client and you need Golang. So please install these prerequisites before your next lecture. And next lecture we'll do it all from scratch, and you'll get a feel for what it looks like to run a network yourself. Okay, with that, thanks a lot, and I'll see you soon at the next lecture.